Hi guys, so after the hyperbola exercise that you've been handing in for me to have a look at, which is looking pretty good, got this. You can see how it relates to the ellipse as well. So hopefully you're building that understanding of ellipses and hyperbole and how they're quite similar. I just thought there's a couple of questions you might want me to go through, having had a look at what you've been doing. A lot of it's been going down really well, but just a couple of things just to draw out and a couple of points to make that you might find helpful, hopefully. So let's have a look at this question first of all. This is question 4. And we've got two things that look relatively similar to each other. We've got 16x squared minus 9y squared is 144, and 16y squared minus 9x squared, we swap the x and the y over, notice, is 144. And then we've got to describe the transformation that would take part A onto part B, vice versa, that kind of thing. Okay, so let's have a look. So let's grab a pen. So if I take part A, we'll do that first. So for part A, we have dividing through by 144, we would get x squared over 9. Yeah, 16 divided by the 144 from here would leave a ninth. And then the 9 divided by the 144 for the y squared would give y squared minus 16. Okay, equals 1. So we've got A here is 3 and B is 4. Okay, and we have for the hyperbola as well, if we remember, we've got b squared is c squared minus a squared. Okay, so we can say here, just rearranging, c squared is a squared plus b squared. So c is actually 5 on this one. C squared is a squared plus b squared. And our asymptotes, useful to have the asymptotes if we're trying to sketch it. So our asymptotes are always y equals plus or minus b over a, plus or minus then 4 over 3, lots of x. So I can then draw that one out, no problem. If I think about part B, okay, I'm not going to draw it just at the moment, but we'll see how these things are related to each other. We've got it just the other way around. Where we had the x, we've got a y. So I'm going to have, okay, in this one, y squared over the 9 minus x squared over the 16 is a 1. Okay, so this time round, I'm still going to say the a, b, and are still the same way around. So b goes with the y, that's still 3. And a goes with the x, that is still 4. Okay, I would now get here, the a and the b need to swap over in b squared equals c squared minus a squared, but notice that gives you the same thing. If I swap the a and the b in b squared minus c squared minus a squared, I've got the same thing round. So I am still going to get c is 5 here, same thing. Okay, remember c squared is a squared plus b squared, that's what that first one is telling us. So it's making no difference if I swap a and b, different way around. Now, I always get, remember, this way around, y equals plus or minus b over a lots of x. I'm going to put this in quotes because that's the standard form that we see when we're dealing with the x squared term coming first. So when we've got this kind of form, this is what we get for our asymptotes. Okay, but we have swapped. The y has taken the position of the x and the b has taken the position of the a. Okay, so we've swapped. So we need to do that swapping in the equation. However, probably most of you are happy about seeing this, and you've seen it yourselves already. If I swap the x and the y over, and the a and the b over in that equation, because that's what I've done, I end up with this. But if I was to rearrange that, I get back to y equals plus or minus b over a x. Okay, so in just the same way that we got going on back up here, just the same way, we've got b squared minus b squared is c squared minus a squared is still true. This is still true. So we can now sketch our graph. What is actually happening? let's do this. I'm actually getting better at drawing straight lines. That's a famous last words sort of thing, isn't it? Oh, that's a bit wonky. So let's draw in, let's do our 3/4 so that when x is 3, y is going to be 4, isn't it? I just do these bits of sketching. And -3 is going to be important. And so is -4. And we know we've got our foci at -5. Okay, and so let's put a -5 there and a +5 there. And we've got the same up here. So we've got a 5 and a -5 for when we swap the other way around. I've made those crosses, haven't I, for the foci? So let's just do that. And the 3s, there are the vertices. And I will also have a 3 there and a -3 there. Let's do that for when the vertices are the other way around. Okay, so let's have a look at how this is going to be. Let's just write that one in. So I didn't finish that bit off today. Let's just put it in. Our B now is 3 and our A is 4, isn't it? So it's gone the other way around. 3/4 rather than 4/3. Let's draw the first one. Sorry, I didn't finish that bit off today. 3/4 of x plus or minus. So let's draw the first one, 4/3. Okay, so my dotted line is going to have to go through these sorts of points. So there's one asymptote. Apologies for how bad this is going to look. And we're going to get one coming back the other way, going through there and there. So let's get our other asymptote in. If nothing else, I've got better at this. And we've got our foci there and our vertices here. So the first ones round just do that, don't they? That sort of thing. Let's draw him on, and that sort of thing. And then what's happened, we're going to get that graph just looking the other way round. What's happened? Well, the transformation you should be describing at this part. Okay, what we're thinking about happening is we're doing a bit of a rotation, really. We're rotating the whole thing through 90 degrees about the origin. All right, because if you picture what's actually going to happen, we're going to have our asymptotes will have moved so that they're less steep. By the time I need to get 4 to get up to 3, yes, this has moved around 90 degrees to give us that. This will move around 90 degrees. And obviously these bits here will end up being across the top and across the bottom. So what's actually happened, we've either rotated by 90 degrees about the origin, okay, in an anti-clockwise direction, or we could think equally that we've reflected in the line y equals x. Okay, so that's going to give us the same sort of thing. If we reflect it over in the line y equals x, the x and the y coordinates swap over. And that's all we're getting. Okay, I'm going to do one of these on question 5. So question 5 here, we need to say where the centre, the vertices, the foci, and whatever, the equations, the asymptotes for each of these. So I'm just going to do part B. Part A follows in a similar sort of way. Centre's easy. What are we doing here on part B? Well, we've subtracted -1. So our centre is -1, and our y coordinate for it is -2. Just got that from the x plus 1 squared and the y plus 2 squared. Okay, we just got it from those two bits, x plus 1 and the y plus 2 squared. We can get then our a and b values. So a squared is 36, so a is 6. And b squared is 9, so b is 3. I can get my focal length because I know that b squared is c squared minus a squared. So c squared is those two squared and added together, isn't it? So c will be the square root of those two squared and added together. Well, we're just back to a root 45 then, aren't we? 36 add a 9. Okay, so we've got our focal length. We can then think about, well, what do we need to say? We need to say where the vertices are and where the foci are. Now, if I was just dealing with this as one that hadn't been moved along, so that its centre hadn't been shifted from the origin, I would be knowing this. I would know this sort of thing. Be knowing. What kind of English is that? So I would know that that goes through minus 6 there. And then we've got the other vertex at 6 here. Yeah. And I would know my asymptotes were y equals plus or minus b over ax. Plus or minus b over ax. All right. We're not going to leave things as 3 over 6, are we? Because we're good mathematicians. We're going to write that as half x. Always simplifying as we go. So we know that things are going to look like that. So if I was to sketch it, let's just sketch it for a minute. So by the time I've got to 6 here, I will only be at 3. And by the time I've got to the negative 6, I'll be at minus 3. So I know those 2 points are going to give me what I'm looking for, kind of like that. And then one coming back the other way through there and through there. So I'm going to get that kind of thing. And there are my vertices. Okay, and my foci are just inside a little bit, where this here would be root 45 for the focus there, and minus root 45 back here. But I've shifted everything along, so the center has gone 1 back and 2 down. So what's going to happen? Well, each one of these points is going to go 1 back and 2 down. So let's just write down what's happening. So our center, yes, we've already got this. It's gone 1 back and 2 down. But everything else would go 1 back and 2 down. So let's think about where our foci usually would be. Our foci usually would be at plus or minus root 45 and 0. But it's gone 1 back and 2 down. So our new foci will end up at the points minus 1 plus or minus root 45 minus 2. Okay, you can work those out as decimals if you want, and I know that's what the book did. But that's where our foci are. And our vertices were at the points plus or minus 6 and 0. But again, that's gone 1 back and 2 down. So our vertices have now moved. When we were minus 6, we'll have gone to minus 7, minus 2, and our other vertex will be when we had plus 6, so that will go to 5 and minus 2. We're just left now with the asymptotes. Now this is a bit trickier, but if you think about what's happening, our asymptotes go through the center of our hyperbola. Our center has moved to this point. The gradients, though, of the lines will not change. It will just shift along, won't it? Okay, so it'll have gone 1 back and 2 down. The gradients of the lines will still be the same, half x and minus half x. So I now know I've got something that looks a little bit like this. I will have y equals, my gradient is still the same, but because of the shifting, I've got some c on the end. Y equals mx plus c. There is a different intercept. It's not going to intercept at the origin anymore, is it? Because it's going to step back 1 and 2 down. So intercepting down here somewhere by the looks of it. Yeah, a bit further down. Let's take the first one then. And we know a point. This is a key thing. Rather than both go through the origin now, they both go through this point. So I can say that I can use this point minus 1, minus 2. And I can use the first equation. Let's do it where we've got half x first of all. Yeah, they're clearly not going to cross the axis at the same point, the half x and the minus half x versions, because look, this is going to shift back, minus 1 and then 2 down. Well, the intercept here will shift to be in a different position to the intercept here. They're going to just be different, okay, because of the way they're shifting. So let's work out. This point is on both of them, though. So minus 2 in this case, the y value, is half of x, half of minus 1, minus half, plus c. So in this case, c has got to be, add on a half to the other side, minus 2 add a half, minus 1.5, or minus 3 over 2 if we like. So that equation, that asymptote, is y is a half x minus 3 over 2. That's what its intercept was, minus 3 over 2 on the y-axis. And we do the same thing for the other one. We know it goes through this point, our center, And we have our equation, y equals minus half x this time, plus c. The gradient of the second asymptote is minus half x. So now we know that minus 2 is minus a half times 1. Well, that's positive a half, plus c. Take away the half to get left with what c is. C is minus 2.5 or minus 5 over 2. And my second asymptote is then in full, y is minus half x minus 5 over 2. Okay, just take a look at that, make sure you're happy about how we've done all of that. I've worked it on the basis that the centre doesn't move in the first place. It just helps me with what's the length of the vertex, what's the focal length, let's work with all of that, what are our equations of our asymptotes, and then just think about how things slide along. The foci slide 1 back, 2 down. The vertices slide 1 back and 2 down. The equations of my asymptotes will have the same gradients, but the intercepts will have changed because this has moved. The point where they cross has moved. So they will be intercepting at different points. So we just say y equals half x plus c, stick in the point that we know they go through, the centre, work out that constant, and then do the same for minus half x plus c. All right, completing the square. So some of you mentioned about this one and saying you're just having a bit of difficulty getting the completing square stuff to come out right. So I'm going to go through one of these ones. So rewrite the equations of that hyperbola so they fit the form of the equation of the standard. So let's just do that then. Let's change to a pen. So starting off, we've got 4x squared. I'm just doing part A, 4x squared. I'm going to bring the other x term with that. Minus 8x. I've got a minus 9y squared, minus 36y. I'm going to take my 68 onto the other side just for the minute, just to get it out of the way. Okay, so the minus 68 becomes a plus 68 there. Take out the factors that I've got in the x terms, the numeric factors that is, before I do the completing the square. And the numeric factor I've got in the y terms. Okay, so that's 9 here, isn't it? Because 9 will go into 36. Now I've intentionally made a mistake at this point, because this is a common mistake to make. What's the mistake I've made? Hopefully you saw that that should be a plus. Why should that be a plus? We have minus 36, lots of y on the line above. Well, minus 9 times the plus 4 will give me the minus 36. Okay, we're taking the minus 9 out really as the factor. The minus 9, and then we need to do that times by 4 to get the minus 36. Just be careful. All right, if we complete the square, let's have a think then. We always half the coefficient of the x and then square, half the coefficient of the y and then square. Equals 68, but we're going to need to deal with some other bits coming in here as well, aren't we? Because this first bracket, going back to my laser pointer, this first bracket, minus 4 times minus 4 at the end would give me a plus 16. I did not have a plus 16, okay? But I've got 4 lots of it as well. So I've introduced an extra 4 lots of 16 here. I need to introduce that on the other side. However, some of you are probably screaming a little bit, going, no, you've made some other mistakes. And I have, haven't I? Let's just deal with that. Did you spot that one? Okay. So don't worry about the fact I made another mistake. I've been able to deal with that now because I forgot. When I took the 4 out as a factor, that was 2, and that would be a 1, wouldn't it? Let's keep these numbers nicer. Okay. Right, so any of you were screaming, no, you've made another mistake. We've sorted that out now. All right? Rubber comes to the rescue. So we've got an extra 1 squared appearing at the end here, an extra 1 times by the 4. So we've introduced an extra 4. Let's put that on there as well. All right, so we're balancing it. The extra 4 we got there and the extra 4 we got there. But what are we getting at the end here? 2 squared is 4, times by 9 is a 36, but we're taking that away. It's extra bits we're taking away, isn't it? All right, 9 times 4. We're taking away an extra 36 on the left-hand side. We've got to take away an extra